you're Anders, and you. And I will talk today about the future of cookies, or also a bit about the history of cookies, where we are right now, and trying to use my crystal ball to find out where we are heading. But it's a bit hard to say because it's a fast-moving area. I should also say that I am working on login systems or an OpenID Connect with the Duend Identity Server, etc. normally, which means that my interest in cookies comes from using them as a good guy for security purposes, using them for single sign-on systems, for persisting a session when signing on to a system. And that means that I want cookies to be working for that purpose. I am not that much into looking for tracking solutions, ad network tracking, etc., and alternative means. I want stable, reliable cookies, because that is what we need. But before we go into that, I have to make a special announcement, and this is where I should bring out my most dramatic voice. So today, at 12, there will be a test. So actually, this is a security conference, and the Norwegian authorities decided to participate with an air raid alarm test at 12. And obviously there will be outdoor sirens, and there will be push notifications to cell phones, smartwatches, etc. And they will go through even if you have do not disturb. So I'm looking forward to hearing all phones going off at once in the room at 12. So don't be surprised when that happens. Okay, back to cookies. So some cookie basics is that when we make a request to a web server, then in the response, the web server can include a cookie in the response. And it does that by a special header, the setCookie header, where it says key or the name of the cookie equals value. Simple as that. And on any subsequent accesses to the page, or any request to the server, that cookie will be included. A very simple concept, has been the same since the 90s, or mostly the same. In the response, there is cookie, flavor equal chocolate chip coming back. What's interesting, though, is that now we are in an era where there are cookie consent banners everywhere. We have the GDPR regulation and privacy awareness. And one could think that that's something new, but if we look back, it wasn't. So this is a very old screen dump from confirm setting a cookie in an early version of Mozilla Firefox, where the browsers originally, in the end of the 90s, when internet first came around, they did ask for consent for every single cookie, because it was considered privacy intrusive when cookies were set. I don't really know when browsers started to accept cookies without consent. But they did. Everyone was using cookies, and everything was fine. And everyone was happy. I was happy too. I had a very fast internet connection. 2 megabit ADSL asynchronous. That's 2 megabit downstream and half a megabit upstream using a ZigZag modem, this version. It had, among other things, a DNS settings page, and when you hit save, it saved it to some, or posted the data to the modem that persisted the DNS settings. Then one day, on an internet forum I frequented, a Swedish security researcher, Leif Nixon, he reached out, or he made a post asking, do I know anyone who has this specific brand and model of modem? And I said, yes, I do. I got a PM in like 10 seconds. Hey, can you click this link? And I was like, hey, do I really want to click this link? What would you have done? Well, of course I clicked the link. Of course I'm curious. So I clicked the link and I got a page, literally a page of kittens. And I went, that was not bad. And then I started thinking, well, I mean, he asked on a forum for people with a specific brand and model of the modem. He sent me PM. He also asked me to not say anything before it was published. So, well, there must be more to this than just showing me a page of kittens. So I checked the page source, and I found he had an iframe with a form mimicking the form I had on my modem, with a script that automatically submitted the form to my modem. And since cookies are the inclusion of cookies is based on the destination where we are sending the request. My authentication cookie from the session on the modem was included. So by just visiting this page of kittens, the DNS settings on my home network had been changed. What's important here also is that this settings page, you see, it's an internal IP address. It's only available on the internal network. So maybe that's why they didn't include proper security on the page, because they thought it is only accessible from the home network. It's me and my family. But the thing is that the evil kittens, they cause my computer that is running on my network to make this request to the internal side of my modem, which is accepted to changes. So this is cross-site request forgery. And things were not that happy anymore. And there were all sorts of things happening in between here. IETF pushed OAuth 2, where we should use token-based authentication for single-page applications. It has since swung back to using cookies. So things were not that good. But in 2016, the browser vendors decided that they should help us developers. Browser vendors stepped in and said that, well, we will help you developers to protect your users from the evil hackers. What they did was that they started offering some more possibilities when setting a cookie. We could now set, so HTTP only, that was an overhead and secure as well. HTTP only means that this cookie is no longer accessible from JavaScript. It will still work in a plain HTTP environment, but if we have a cross-site scripting problem on the site, the malicious JavaScript will no longer be able to read the cookie contents and exfiltrate it. Secure means that this cookie will only be sent to HTTPS requests. So if someone was able to mount a downgrade attack on the site, the cookies would not be included. But the great news was SameSite. So remember, the cross-site request forgery, the evil kittens were able to succeed thanks to the cookie being sent to the modem, just because the target of the request was the modem. In the original model, the browsers did not consider whether I had loaded the page from the modem or if it was the evil kitten page that tried to post the form. With SameSite, that changed. So setting a cookie to SameSite strict meant that this should only be included if the request was initiated from the same site. And to be backwards compatible, they kept saying that, well, if you do not specify SameSite value, the cookies are fine in all scenarios. That would be the default. They introduced strict, saying that, well, cookies are only sent if they are initiated from the same site. But this turns out to be a problem. So for example, consider that I'm using Outlook.com, webmail. I get a link to the company internal system where, hey, can you please check this customer record? So it's a link to crm.example.com/customer x. If I click that link in Outlook.com and try to open it in the CRM system, that of course requires log on to check a customer record. That is a cross-site navigation. So if the session cookie in the CRM system is strict, then it will not work. And that is a bit awkward, isn't it? We want to be able to click a link and get into a logged-in system, but we do not want posted data to be able to make it cross-site. And that's where Lax was introduced. So if you're doing your HTTP verbs right, GET should never ever change the state on the server. Post, put delete, that changes state. If you set a cookie to SameSite Lax, it means that it can be transferred in a GET scenario. In this cross-site navigation, I can click Outlook.com, I can open the link, which goes straight to my CRM system. But when I want to save and update the customer records, I need to do that originating on the CRM system, and that's fine. So things were not, well, this was a good feature. The problem, this was a good feature. So let's talk about sites. What is a site? Because this was SameSite. Are these the same site, do you think? They are actually the same site. They are not the same origin, but they are same site. So the idea with SameSite was that we wanted to isolate between completely different companies, attackers, but as soon as you are within your own domain, well, whatever, if you want to navigate and share and use cross request across different parts of your system, between different web servers in your own system, that's up to you. So they're SameSite. What about these? Well, they're actually not, because the scheme is included in the decision. So it looks fairly simple, doesn't it? If it's HTTP, if it's the same protocol scheme, and if it's on the same, under the same top-level domain, that's fine. What about the UK? You can't register anything directly under the UK. You get under co.uk, so you don't get a second-level domain, you get third-level domains. Well, those are actually considered different sites because those are publicly possible to register. What about these then? Azure websites.net, github.io, things like that, where people, you can go in and create an Azure, a website on Azure websites, and that will create a new name under Azure websites.net. Well, they are also not considered the same site, and all of these rules are in the public suffix list. It's actually it's published on GitHub, I think, and it's possible to submit new domains. You need to prove that you are in control of the domain. But if you offer a service where end customers can publish things, it's a good idea to be on the public suffix list. So SameSite helped a lot. And all the things that the browser vendors did. I mean, cross-site scripting in JavaScript, if we mark our cookie as HTTP only, JavaScript can no longer exfiltrate the cookie. The downgrade attack, well, secure flag means the cookie is no longer sent. And CSRF, cross-site request forwarder, all SameSite mitigates that. There is one problem, though. Look at how we do set the cookie. We send along all the flags when we set the cookie, but when the cookie is consumed or is used, it's only the value. So when the web browser receives the cookie, there is no way to know if it was actually a secure cookie. It could be a cookie that was set by malicious JavaScript. So let's talk about domain-wide cookies. I did some consulting work for an American university some time ago. And being a university, I'm sure they had some admin stuff that I was working on, and I'm sure they had a computer science department where they somewhere have a web server running where students can publish their own projects. That's likely to happen at the university, right? What if the students do this? They set the flavor cookie with the domain of abc.edu. That means that this cookie should not only be sent back when accessing the student project site, it should also be sent back to any other host under abc.edu, such as the admin site. And the poor admin site has no way to know if this was a domain-wide cookie or if it was a legitimate cookie that it set itself. But once more, the browser vendors came to our help. So there is, they didn't want to introduce new header fields because introducing new fields in how the cookies were sent back to the server, that would be a very breaking change to every web server around. So they had to figure out something else. They came up with a name prefix. So if you name your cookie __ secure and then something whatever, it starts with _ secure. That cookie must be set using the secure header. Otherwise, it's rejected. And there's an even better version, the host. which requires the cookie to be set as secure. It should not be a domain-wide cookie, and the path must be to the root of the server. It cannot be to subdirectory. So this is really what we should use for all session cookies all the time. Name them __ host. As long as we know that we will not publish our application to subdirectory, of course. So things looked good, right? They looked good all the way up to 2020. When the browser vendors started to think that, hey, especially Chrome, say that, well, this SameSite thing we offered in 2016, we tried our best to help out to prevent cross-site request forgery by offering this. But the adoption rate was very low. So what they wanted to do, they wanted to change the default. So change the default from being allowing to, so the default same-site behavior cookies switched to be lax, and there was a new attribute introduced, none. So if you wanted the old behavior where the cookie was always sent, you now had to add same-site equal none. How many of you had to fix your systems to include that? Well, a few. But there was yet another problem with this. If we did, the old spec said that if there was an unrecognized value, then to be safe, the browser should treat the cookie as being same-site strict. In the original spec, there was no none value. So when old iOS Safari on older iOS versions started to seeing an explicit same-site equal none, they didn't recognize it. So when you sent same-site equal none to iOS, they treated the cookie as same-site strict. So that's when we ended up with this beautiful code. Don't ask me exactly how this made its way to me, but the rumor is that this is actually essentially copied from Azure AD. This is what they did to fix Azure AD. Sniff user agents to know whether to send same-site none or not to the browsers. Well, it kind of worked. If you have code like this, you can now ditch it because those old iOS versions are out of support. So all currently supported versions of browsers do support same-site equal none. So far, the browser vendors helped us a lot with adding security. But there is another thing that happened that the website vendors reacted to. Have you heard about the Facebook pixel? Which isn't actually a pixel, but it's at least something that you include on your web page, which includes a reference to facebook.com, downloads data, which means that if the user is signed into Facebook, then Facebook will correlate and build a massive web history. And what's worse is that Facebook actually as far as I know, they at least used to create a profile for people that did not have Facebook's account. So even if you didn't have a Facebook account, Facebook had an account for you and a profile for you because they were able to follow you around the web. So I was very late to the Facebook party, and I found out that, well, Facebook knew that I existed because of other people around me, friends and family, that had Facebook. That's a bit scary. So what happens here is that when we load the page, we issue a GET request to our web server, but there's also a GET/tracker request to Facebook, and that includes the cookies. And the cookie here is a first-party cookie to our own website and a third-party cookie when we request the resource from Facebook. And now the browser vendors came out and say that, well, we want to help. It's not only the hackers that is the problem, it's also the ad networks and, well, some companies. But the problem here for us as developers is that the browser vendors now say that, okay, wait, if we have a cross-site scripting vulnerability, we didn't deliberately include that on our site. But who included the Facebook pixel? Well, developers. Developers are on the bad side. And now this is a major change because so far everything we've covered. Hey! It's time. Okay. And test. You have to dismiss it, right? The developer?
You can't say that developers are on the bad side.
Well, I don't think developers are on the bad side. It's just that the browser vendors started to treating us. Again?
You said that again.
Okay, so the problem is that if I say that, then it sets off. Okay, so developers are good guys, but the browser vendors placed us on the right-hand side of the slide. So what I want to say with this is that so far all the new features that the vendors yes, all the new features, if I'm saying something bad about the vendors, all the new things that the vendors introduced that we covered earlier were things that were meant to help us. And we could use them. But here they started to do things to prevent us from including Facebook tracking. And that means that there is, SameSite, they offered an excellent way to opt in and out of the SameSite protection through this new header. But they do not offer a way to opt out of third-party tracking. So let's see, why is that a problem? Well, one thing that also uses a hidden iframe is the OpenID Connect session management specification. The OpenID Connect session management specification for single-page applications says that the client application should open a small hidden iframe that reads the check session endpoint of the OpenID Connect provider. And when it does, the OpenID Connect provider's session cookie will be available inside that iframe, and that enables a clever JavaScript-based eventing system where the OpenID Connect provider can send a JavaScript event when the user signs out. And a similar thing is also used for renewing access tokens. When third-party cookies are blocked, this just breaks. There is no way around it. So this is the reason why Brock Allen discontinued his OIDC client.js library. It was a certified OpenID Connect implementation in JavaScript for single-page applications, but it turns out that there's no future to it because the browser vendors completely killed the features that this spec depends on. And it's not an implementation thing that can be fixed. It's the mechanism that the spec is using. Another thing that might break is single logout using front channel. So actually when we go to, this is the end server example, it's the same with Microsoft Azure AD, Entra ID, or any other feature, or any other identity provider. When you sign out, there is a page which loads a bunch of hidden iframes which notifies each client application participating in the session, it's time to log out, it's time to log out. And that is the only way to clear the cookies on those. The identity server cannot clear cookies on another host. So there must be a request to the client application, the client hosts, to be able to clear the session cookies. And this is the reason we are now recommending back channel logout, where the notification happens on the back channel. The problem with that is that now the server needs to be stateful to know about the channels. So, is there anything more that breaks? Well, let's have a look at Safari. Safari has been among the major browsers have been early on with privacy protection. I know there are specific browsers such as the Brave browser that are really focusing on privacy, but that's a niche browser. I would assume some people in a room like this uses Brave, but the general public no. But the general public, do they use Safari? Yes, they do. So consider if we have shopping.com, which uses cloudlogin.com for signing on. If a user goes directly to shopping.com, then it will not. Did I say something bad about Safari again? Is it mine too? I think they warned there will be, no? It's an interesting sound. What Safari does is that it blocks third-party cookies from shopping.com if you haven't interacted with cloudlogin.com before. So if a user would have first interacted with cloudlogin.com, then go to shopping.com, then cookies are allowed. This is quite clever, because if cloudlogin.com is a login server or login provider, it's quite likely that you have actually gone there and logged in, right? You have interacted with it. But if it is an ad network tracker, have you ever, I don't think I ever have, and I'm a curious person, I don't think I ever have gone deliberately to interact with the cloud network trackers.
You never visited Facebook?
I never visited Tushia. Yeah, I use Facebook occasionally. So far, I think Safari helped us, but they are doing more things. They introduced intelligent tracking prevention, which uses AI. And I don't know what your opinion on AI is, but I'm not very impressed. What they do is that they track if something is used from many sites, if there are signs that this could be a tracker. So if we are including a resource from another domain, or we are just including a few, just a few applications are including a resource from a shared host, like 2 client applications using a single sign-on server, then it's fine. But if there are hundreds of sites, or many sites, that include an ad network tracker, then they can recognize that. They do this for sub-resource items and bounce tracking, and then they remove the cookie for you. So if your single sign-on solution is successful enough so that many sites use it, then Safari will block it. They will do this for sub-resources like JavaScript assets, things like that. They will do it for iframes, which is reasonable, and also for top-level redirects. Because what happened here was, of course, that, well, when the ad networks found out that, well, our tracking pixels are blocked, they started doing a quick redirect over and back. So they redirected the top-level window and back. That's exactly what we do with single sign-on. So that's bounce tracking, and Safari may or may not block it. And what's horrible to me here as a developer is that so far, all of the other things they do, I mean, the previous one here, this is a bit, it depends, but it's at least reproducible behavior. I can reproduce this, and I can test it, and I can know whether it will work for my users or not. This thing is pure guesswork. But if they remove the cookie, well, you just ask the user to sign in again. Could they make it worse? Yes, of course they can. They actually go and change your SameSite property of your cookies as you have already set. And I mean, so on an identity provider, typically the main session cookie must be SameSite none to be accessible, or SameSite Lax at least, for logout to work. Because logout singles, when you sign on, you can have interaction. But logout notifications requires that the cookie is picked up. So if they change it to strict, that means they are breaking logout for existing sessions. And to me, this feels bad. Because if a user fails to sign in, you will have them on the phone. If a user clicks log out, and the browser displays you are logged out, the user happily walks away. And if they are still logged in, we have a security problem. Okay, so Safari, they are doing more things. So, well, when trackers find out that, so shopping.com uses tracker.com, and they found out that, well, it's not possible to use cookies to track the users anymore. So what if we use browser fingerprinting, IP address, user agent profile, things like that? That could be used to track users instead, right? So what if we just set a CNAME to tracker.com, because now it's SameSite, then we could even set a cookie, and tracker.com could do some advanced analytics to try to combine different cookie values in different domain, matching them using the user agent profiling. Well, Safari blocked that. They found out that, well, it's a CNAME to a tracker, block the request. Next step, let's do an A record. And I actually studied with John Wilander, the engineer at Mozilla at Safari, who has been working on this, and he is very persistent in what he is doing. So he, of course, wanted to make sure that this was also blocked. So what they did is it was an undocumented feature in Safari 16.4 released in April last year that they are comparing the first 2 octets of the IP numbers of the different hosts within the site, and if they are different, Safari treats them as trackers. So if everything is working perfectly fine for you, and then you start the migration to another cloud provider, which means you get another IP number series, during the transition phase, when you run your system on 2, or you simply just run from 2 cloud providers, or you happen to get 2 different IP number blocks. I mean, if you use Azure, it's quite likely that they have very different IP number blocks. Safari might start blocking your stuff. Okay. So let's leave Safari. Let's look at Firefox, total cookie protection. Sounds good, doesn't it? So, well, the idea is that if you are visiting shoes.com and diamonds.com, both are making use of Facebook tracking pixels that would have used the cookies to see that, well, the same person is both looking for shoes and diamonds. This will be expensive. But what Firefox took another approach. They created 2 separate cookie jars. So if you load the Facebook tracking pixel from shoes.com, the cookies work. But the values of the cookies are partitioned and saved in the cookie jar that is attached to shoes.com. So when you then go to diamonds.com and load exactly the same tracking pixel, there is another cookie value present. So there is a partitioning of the store depending on the top-level site you are navigating from. I think this is quite clever because it means that it doesn't remove the cookies without the developer having a say. The cookies are there. If you set a cookie in one context, you have the cookie. It will be there. But if you try to move to a completely different context, it will not. It will be another value. They also somehow detect single sign-on and have exceptions. So, for example, if signing into Microsoft Teams on Firefox, it will actually ask, do you want to allow cross-site cookies in this scenario to use single sign-on? So what did we have? Safari, well, they were blocking early on. Firefox, they're blocking. Edge, not so much. Chrome, we'll come to them. But just a question, why would it be that Safari are so eager out of the major browser vendors to do this? Well, how do Safari and Apple, how do they make money? Selling phones, of course. And they sell more phones because privacy is actually a feature they advertise sometimes. Firefox, they got the money from Mozilla Foundation. Microsoft with Edge, they got their money from selling Office, and they want as long as Office and line of business application works, Microsoft are happy. Google, where do they get the money from? Yep, exactly. So Google said that, well, the other vendors, they are doing this privacy blocking. We must do that as well, because privacy will be a feature in the future. And then they claimed to want to be responsible. So remember the SameSite when they rolled it out? They actually rolled it back during the COVID outbreak, the SameSite changes. They postponed it because when Google pushed out, they are the major browser, and if their new update made important healthcare sites stop working, and that's not a good thing during the pandemic, so they took a step back. So for the cookies, what have they done? Well, in 2020, they went down to say that, well, we should give a bit of a warning. We will retire third-party cookies in 2022. And then they looked at the market, and in 2021, they went down to said, we will retire third-party cookies in 2023. In 2022, they went out and said, we will retire third-party cookies in 2024. Then they went out in 2023 and sticked to 2024, actually, but just for 1% of the users. And it went in effect 6 days ago, January 4th. I was one of the lucky ones. On my phone, I got a notification saying, hey, you now have extended protection enabled. I haven't so far noticed anything that has been broken. But it will be interesting, and it would of course have been great if I could tell you the results here, but it's just 6 days ago and there is really no information. It's been a weekend as well, so there is really no information out there yet, but it's definitely something to keep an eye on. They've also said that by December this year, they will up it to 100%. So there are announcement posts around. It's possible to create a feature flag in to set a feature flag. It's listed here. How you set a feature flag in Chrome to make it active if you want to test it. So this is what it looks like. Third-party cookies blocked. I just went to a major Swedish newspaper owned by Schibsted and thought that they are probably setting a lot of cookies. They did. So what about the ads then? I mean, Google, they're still making money from ads. They still would like to have something to track users' interest, right? Well, they created a new API in the browsers, the Privacy Sandbox, which contains methods to be able to have flag that this person is interested in buying a new car. So show him car ads, or her. Things like that is done in a separate API nowadays. It's just that solves the ad problem, but if we look at a single sign-on perspective, it doesn't solve that. Because single sign-on, in OpenID Connect, front channel logout, session management, and iframe-based background token renewal will fail, as well as all iframe-based login widgets. Another pattern that is common when a common usage for do-end ident server is to use what we call a federation gateway. Remember that I said that Safari made an exception based on the fact that you are probably interacting with the login server, right? But a common pattern to use, if we have an external provider, we have multiple applications on an external provider, is to chain two login servers. So the idea here is that a user that goes to one application, they are jumping all the way to Microsoft Entra ID or whatever it is to sign on. That's why they enter their credentials. But to not have every single client application having to be set up with Microsoft, we put an intermediate OpenID provider that is invisible, no UI, nothing. It's just an aggregation point and possibly protocol translation point. We call it the federation gateway. So in this case, the user has interaction on two of the sites, but not on the interacting. So I look forward to seeing the federation gateway pattern being affected. So what does Google think about sign-on? I mean, sign-in with Google is one of the major ways websites allow sign-in. What are their plans? They added another API, Federated Credential Management API, which is essentially, you've seen this sign-in with Google, this little box popping up. I think this is scary. I mean, I go to a site, and that site has, it's an iframe, obviously, but still that site gets to know or can display who I am without me ever consenting to sharing this with the site. So the Federated Credential Management API actually formalizes this in a way that it makes it impossible for the hosting site to get account information before the user has consented. That is good. What is not good is that they are solving the Google problem. And the Google problem is that there are a lot of consumer sites out there where Google wants people to be able to sign in with Google. And you're already signed in with Google in the browser, right? So this solves the problem where you are already signed in and you want to use your existing session from yet another site. In a corporate setup, where we provide custom login service, I mean, we cannot assume that you are already signed in. And a single sign-on protocol is as much about establishing the session, initially signing on as single sign-on joining the existing session. And that is not part of the spec. So this is, Google solves their problem. Also, there is no logout. I mean, Google is mostly OpenID Connect compliant. It's a fairly good OpenID Connect implementation, sign in with Google, but they do not offer an end session endpoint. They do not want a way to make it simple to sign out of the Google account. They want you to stay signed in. So while this solves the consumer problems somewhat, and will emphasize the usage of the big social networks, then it doesn't solve the generic problem where you have your own provider, and line of business problems is not solved at all with this. Okay, so what can we do? Well, there is a term called super cookies. I just want to mention them, but they are not cookies. So super cookies is what ad networks can use other means than cookies to track you. It's clever use of HSTS headers. It's other kind of data fingerprinting. So whenever you see the term super cookie, from a strict technical perspective, they do not most often not mean cookies. They mean something else, which is reliable to a good extent, 90% reliable maybe. And 90% reliability is good enough for ad network tracking, but not for security. So super cookies will not save us when we want to use cookies for security purposes. So to wrap it up, cookies going on, it's a first party or same site concept. Using cookies in cross-site scenarios will be very hard in the future. I think that's where we will end up if I look into my crystal ball, which means that single sign-on for now with interaction will probably work. And especially if you use the well-known protocols, OpenID Connect, SAML2, etc., I think the browser vendors will be testing their implementations with the standard single sign-on solutions. But without interaction, it's more questionable. Single log out, on the other hand, the front channel single log out is dead. Back channel is the way forward. We need to move state to the back channel. So that's what I had. And I hope you're not too disappointed if you get lunch a bit early. But of course, I have time for questions. Yes?
I just want to go back to earlier on in the presentation because it caught my eye.
The public prefix list.
Public prefix list, yeah.
This is public suffix list. This one? Yep.
Yes, yes, okay. So does that have to get updated in the browser? Does the browser have to be updated in order to update that list, or is there some other way of having that list?
So the browser somehow has this list, obviously. I don't know how the update works, if it's embedded in and pushed out with new versions. It is, with new versions of the browser. So they are not downloading it. It requires... Not on the fly. Okay, thank you for helping out there. But the list is available, so you can go browse the list and read it.
Yeah, like, there's always going to be a delay.
Yeah.
I'm setting up a public suffix that I want to let people set up. If I want to rely on that for CSRF protection, there's going to be a delay of
Yeah.
submitting it getting rolled out to the browsers, and people actually updating the browsers, which may or may not happen.
Exactly. It may or may not happen. So yes, that's true. And there's also, if you are setting up and saying, hey, I'm this one-person startup, I plan to take over the world, I need to be in the public suffix list, then they will probably not accept you. I think that to be accepted on the public suffix list, I think you need to have some traction at least and usage of your site, and you also need to prove that you are in control of the domain. If I remember it right, it was some clever thing that you need to, I think you need to add a text record with a pull request number to the DNS. It was something like that. So you create a pull request, then you go to your DNS record and DNS and set up just as a proof that this is something legitimate.
Okay. So I guess the bottom line here is it sort of pushes back the death of CSRF a little bit, because in a lot of situations there's still going to be an alternative protection and not just SameSite.
If you are creating a business where you let end users publish things, and by publishing things, I mean if you let end users publish things in a way that they can issue cookies, then you need to protect between the different hosts or different customers. And ways to publish cookies means they can either control the response headers or they can run JavaScript. Yes?
Two quick things. Worth mentioning also that the public suffix request is used in loads of other contexts beyond just browsers. Like if I set up yourbank.myfreewebsite.com and someone decides to block that phishing page, then obviously you don't want yourfreewebsite.com blocked. You want just the subdomain. So it's used for loads of other things.
Yeah. Makes sense. So can I just repeat that? So all here. So if, for example, you set up a fraudulent mybank.azurewebsites.com and that is blocked as a fraudulent site, they're obviously not blocking just Azure website, entire Azure website or not, but that subdomain, because they understand that they are looking at the public suffix list. And you had something more?
Yes, I was just wondering the so-called AI in Safari.
Yep.
That sounded, I wasn't aware of that mechanism, but that sounded an awful lot to me like the same type of logic that Privacy Badger disabled because it could actually be used to track users. Are you familiar with that?
So you say that this sounds a lot like what Privacy Badger disabled because it could actually be used to track users. I'm not familiar with that, but I'm not surprised. And when preparing this talk, I found a lot of material like the ad network community. They are finding very clever ways to more or less reliably track users without using cookies. But me coming from a security and identity management background, I want 100% reliability when users are logged in or logged out, which means I haven't gone that far into alternative means of tracking. I can say, though, that the ad network community, that was just about the only thing I found about the Google rollout now, the January 4th. It was some tweets from the ad network community being quite alarmed, saying that, well, we need to change our business model. Chrome is destroying us. So if there's not any more questions, thank you for having me. Have a great conference.